Hello everyone, welcome again to my mathematics tutorial number 23, dated 19th June 2025. My name is Mr. Lovex Israel Orengo. Today's topic is vectors 2, part 3. In part 1 and 2, I talked about three-dimensional system. I talked about Poisson vectors in three-dimensional system, magnitude of a vector in three-dimensional system, Poisson vectors in three-dimensional system. We talked also about adding and multiplying. That's operation of vectors on three-dimension system. In this section, I'm going to talk about proportional division of a line and parallel vectors and coordinality. Welcome. Proportional division of a line segment. Consider vector AB, which is 5 vector A, and below P, Q, and R are points on AB as shown. Now that vector AB is from here up to here. It is having 5 vector A. That's vector 1, 2, 3, 4, 5. It's going to 5 vector A. Then we have vector P here, which is 2 vectors from A. 2 vector A from A, and it is a distance from B. Also we have Q here, which is one portion from B, and R is outside line AB. Now in this case we say, note that P and Q divide AB internally, while R divides AB externally. Internal division means that point which is dividing the line is within the line. For example, P and Q. But the external division involves the point which is dividing the line segment is on that line extended. For example, R implies external division because R is outside the length AB. It is on AB extended. Now, in the ratio in which P divides AB is given as this. In which ratio does P divide AB? We move from A to P, those are the 2 portions, and from P to B, which is 3 portions. Therefore, AP ratio BP is 2A ratio 3A, which is 2 to 3. Therefore, P divides AB in the ratio 2 to 3. Now, for point Q, Q divides AB in the ratio 4 to 1. For point R, R divides AB in the ratio AR ratio RB. AR, those are 8 units. Then RB, 3 units, but in opposite direction, because vectors are sensitive in terms of direction. Therefore, the R will divide AB in the ratio 8 to -3. Now, the negative sign in 8 to ratio -3 indicates that point R is on AB extended. That's external division. Let's talk about ratio theorem, which will help us in proportional division of a line. According to ratio theorem, if a point P divides a line AB in the ratio M to N, then the position vector of P, the point which is dividing the line, is given as OP or P, which is the second part of the ratio over the sum N or over M plus N times the initial point of the initial position vector, then plus the first part of the ratio or over the sum times the second part of that vector. That's the portion of the terminal point of that vector. Therefore, they interchange. They interchange. Therefore, the first, when we take the first part of the ratio takes the second part of the vector, and the second part of the ratio takes the first portion of the vector. That one will be maybe demonstrated in this example 1. In example 1, in the figure below, OA is vector equals to vector A, and OB is equals to vector B. A ratio M, AM ratio MB is 2 to 3. Given that A equals to I minus 2J plus 5K, and B equals to I plus 3J minus 5K, calculate the length of OM. OM is the length from O to that M. Now, before we get the length, we have to get its position. That's position of M. Now, as I have demonstrated here, I say that in ratio theorem, the ratios would interchange. Therefore, the ratios are 2 to 3. Now, these 3 would correspond to the vector OA, and that 2 would correspond to the vector OB. Therefore, M divides AB in the ratio 2 to 3. Using ratio theorem, therefore, OM, the portion vector of OM, would be 3, the second part, or over the sum times the first vector OA. 2, that's the first part, or over the total times the second vector OB. That is 3 over 5 into this one plus 2 over 5 into this one. Opening the bracket, this gives us 3 over 5I minus 6 over 5J plus 15 over 5K plus 2 over 5I plus 6 over 5J minus 10 over 5K. I've decided to leave all the fraction in as to the denominator of 5 for simplicity in operation. Now, for I, write them together. I take 3 plus 2 all over 5, which will give me 1. Then for J, I take negative 6 plus 6 all over 5, which is 0 all over 5, which gives me 0 for J. For K, 15 minus 10, that's 5 all over 5, give me 1, that's K. That's the portion vector, that's the portion vector of point M. Now that this is a portion vector of point M, its length will be 1 squared plus 1 squared, the coefficient of I and K. For J is 0. The answer is 1.414 units. That's correct for significant figures. Now let's talk about parallel vectors and collinearity. If A is a parallel vector to B, then vector A equals to KB. This shows that A is a scalar multiple of B, where K is a constant. Consider lines AB and PQ with coordinates A -2, -4, B 66, P 53, and Q 1 -2. Activity 1. Find the gradient of AB and PQ. What do you notice? Solution. For AB, gradient is changing all over changing x. That is 6 minus -4 all over 6 minus -2. That is 10 all over 8, which is 5 all over 4. For line PQ, change in y is -2 minus 3, which is -5. Change in x 1 minus 5, which is -4. Simplifies to 5 all over 4. We notice that the two lines have the same gradient. Therefore, they are parallel. Having known that the two lines are parallel, therefore it means vector AB and vector PQ are parallel. Now let us see the property in parallel vectors in terms of vector method. Activity 2. Find vector AB and QP. Vector AB is 6 minus -2, 6 minus -4, which is 8, 10. Vector QP is coordinate of P minus coordinate of Q. 5 minus 1, 4, 3 minus -2, 5. Now activity 3. Express AP in terms of QP. Now that means that we divide vector AB by QP. When we are dividing the two vectors, we divide corresponding coefficients. For example, in AB, the x component is 8. We divide by the x component of QP, which is 4. We get 2 as the ratio around x component. Then the ratio around y component is 10 divided by 5, which is also 2. And B, this is possible only if the ratios for x, y, and z components are the same. Therefore, we can only express a vector as a scalar multiple of the other if all of these ratios are the same. For this case, there were 2, all of them are the same. Even if there were to be 3, they must be the same. Therefore, it means that, in conclusion, two vectors are parallel only if they are a scalar multiple of each other. For example, in this case, we can say vector AB or vector QP equals to 2. That means that vector AB equals to twice vector QP. That's by multiplying both sides by vector QP. Now, collinearity of points. 3 points are collinear or lying on the same straight line if any two vectors involving the 3 points are parallel and have a common point.